Okay, this part that is sense point is basically when the robot moves and touched, it gets near to the objects. If the sensor detects any object, then it will just write that's the point that was sensed, and the sense part, the definition of the sense part, what was it. So we will close this and we will go back to the station logic. And so far we have now a line sensor. We need somehow to attach this sense part to the gripper or the vacuum gripper. So for that we will create basically what is sensed with an attacher. So attacher is the block that will attach what is sensed by the line sensor to be picked up. So sense part will be connected to the child as a sense part. But again, we'll put this as a null, this one also. So we will see how it behaves later, because the sense point or sense part should be the boxes basically, and the execution comes out from this point. And yeah, so orientation, everything we have now. Then we have to define a logic gate again. So we will put logic as our latch. So it is just for set and reset, that if we have set it, then it is grabbed, and when it is delivered by the robot, it should be resetted in order to release the output, or make the reset at the output. So we will put here a logic as our latch here, and execute as a set, and the output goes to the do attached. Now we need to detach when it is delivered on the pallets, right? So again, we need now a logic, but this time as a not. If it is not attached, or if not, if the attach or the file or the comment from the attach is not, then we have to use logic gate. So let me see the properties as a logic gate, and here you see that the default definition is AND, so you should change it to not. There is no delay and nothing, so everything is again what is. So you will connect this to input 1 or A, and then you will need a deattacher. So for that, just thinking deattacher. Oh, where was that? So action, I guess, yes, deattacher. So you need a deattacher, and deattacher from the output could be executed, right? And from the child here should comes again to this child. So the sense part basically. And okay, and this is, let's close this, and then so it will be deattached from the gripper and will be attached to pallets, right? So we could actually define the attacher, the next attacher in the pallet basically, or the outfeeder. But we can also define it here. So the attacher number 3 or number 2. I need to get rid of this. Make it a little bit close. So the child should be connected to the child, of course, and the execution should be executed to this one. So this one, the parent, basically you can define here as the Euro palette, right? We have Euro palette, but again we have to define the Euro palette underneath the outfeeder. So it means that I need to go select this Euro palette and put it under the outfeeder. Do you want to reposition your palette? Yes. So if you go to the outfeeder, you see that the Euro palette is actually a sub branch of this outfeeder. So now when I go to attacher, I can see that the Euro palette is now a part of outfeeder. So yeah, so I will put this as a parent to be attached on the palette, and click apply. I've already applied, and close. And then from here we need to define this. Okay, when you are executed, it means that the one cycle is done, so reset it, whatever. So put the do attached finalize, so 0, because the process of pick and place by the gripper is done. So something like that, something that I am not sure is that why my line sensor has already sensed something, which does not make sense, because the position of my robot is actually on top and the packet is actually here. So why it is sensing something? Basically it's sensing itself, which doesn't make sense. I would like to figure out why, basically, but we can figure it out later probably. Okay, now we go to the station logic and go to the out feeder, because this is the last part that we need to find. So again, some wiring that I need to delete, unfortunately, because this block was defined, as I said, in the library, so I don't need it. The only block or the input that I need is digital pallet time and digital output pallet out. So for this one, I need to go to find out what is it. Okay, so again, we need a source because it's gonna move, right? We need a source, of course. So the source gets its execution from this wire, and the source itself, of course, it's your pallet, because it's gonna move with this, and then we need to somehow define the position of this Euro pallet, because at the moment this Euro pallet position. So okay, so I would say that we position our source somewhere like here, and apply. Okay, the position of this palette is actually not completely well defined. Okay, I guess we need to basically, for the source, and instead of defining this position, which I actually selected from here, I would like to move this before. So I will go to the palette, select the palette, and then try to move this like that. So we are almost on the conveyor, and then I think we need to basically, for the pallet, to define the position which is somewhere on the pallet. The question is that how we can, the side is kind of clear. Like this board, I don't know. Then, so this point basically defines the position of the source, which here is actually our Euro palette, and then apply. And when we go back to the out feeder, okay, then we have to move it, so we need a linear mover, and the linear mover needs to point the source to the object, of course. And if we click on this one as well, we need to define the direction. So the direction for us is in y-axis, so this way, and minus, it should be minus. I don't know how long it is. I think I need to measure it. So this conveyor from here until here, I think it's too much, so I would consider somewhere. Okay, again, I need to actually consider here, this point, until, I don't know, here. So in y-axis is 2858. So we need to make the direction in y minus 2858 millimeter. Okay, and the speed, we can set the speed to 500 millimeter per second, and global, and then we can apply. Alright, so we have a linear mover with the correct orientation. Then we need again some logics. So we need the SR logic SR latch. So this one also means that when the pallet is detected, it sets and it moves as an output the pallet forward, and somehow it should be also stopped. So we need again a planner, a sensor at the end of the out feeder in order to point out that we need to reset. And this sensor, we need to also define the sensor position. So for that, we need to go to the end of this. So yeah, I need to disable this one. Okay, orientation from let's say we consider this part as the orientation, the axis in X, like to be like, I don't know, 300 and 0, and then maybe axis number 2 400. So we should see our, of course it doesn't make sense, sorry. So 400. Let's see if we can find us. Well, I can't find it. We'll try again. So we define again the position. We want to be like here, and then in x1 axis, let me see how big is actually the width of this. So in x-axis almost 1 meter. So okay, almost 1 meter, and let's say 300. Okay, it is something's appearing, but it appears somewhere like that, which I don't understand why it is there. So the position needs to come a little bit higher. So 400 is that axis. We need to bring it a little bit higher. So like, let's say 500. So okay, it's a little bit higher. And then we need to shift it, the origin, to let's say 300. Okay, we are now. So sensor is not really perfect, but let's say 100. It is almost there. So this area, if it is covers, we can also make it 0. So that's if the pallet comes in this area and it is detected, it will be detected by this sensor. But this is just a definition. You can basically do it better than me. So we have now defined the plane sensor. If the plane sensor detects, it will reset the movement of the pallet on the out feeder. And then we have to also define something here. There's something here that I am not as well sure. As I said, the logic that says that, okay, the gripper pick up the packet and put it on the pallet if it needs there to somehow attach it to the pallet, or we can also try this way. So we can define a volume sensor, for example, which is also on the pallet. So I will go to the sensor and select a volume sensor, and this volume sensor needs an attacher. So I will create an attacher here as well. So what is that? The sense part detected by the volume sensor should come as a child to the attacher. So it means that you need to attach to this part if you are detected. And if we go to the attacher, we need to define the parent. So I will define this parent as your pallet, and the child could be the gripper. So for example, this one. This is just an idea. So apply. So then for the volume sensor, we need also to define the location of this point, where it is, or the corner point of this volume. Then we need to go to the station, and we need to go somewhere here, and then say that, okay, this is my corner point, for example, and if I say that it is like 800 the length and 1200 the width, so we have created, if you see this, it's actually completely false, but you understand what I mean. So the height, I don't know if we can make 5. Okay, we cannot. So I will make it like 500 or 700. Then I need to basically rotate this guy. So I need to bring it on y-axis, maybe 90 degree or 180 degree. So now it is basically, now I am putting something on the top of the pallet, and but still it's actually very big. Why? 0. Okay, so this is all right, but we need to go, I guess, higher. So 1000, for example. So this area, and then we need to move maybe a little bit more, 3000, and then we need to move it to the z-axis. So like, I don't know, maybe 700 or even more, 1000. So we are almost there. So anything that comes in this area will be detected, right? Yeah. So this is the area that the object will be created. So I could actually move it a little bit also in y-axis. So 2500 maybe. 2000. Okay, that's completely false. 3000. 3500. Oh, that's too much. 3200. Okay, cool. Now we have defined the position of this sensor. Very well. So we have almost defined all the logics that is required basically for this simulation. And as I said, I have some doubts about the vacuum, but because it sends something strange. Maybe I can also figure it out why. For example, if I move or if I jog the robot itself, so I come here, say that okay, jog, and then when I come, I don't know, maybe this way, like this one, or go down, 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 down. So we're almost at the conveyor, right? Okay, now I'm totally wrong. So I need to move like this and see if I go down again. Yeah, if I go down, the idea is that if I can actually touch, so like that, and we are almost touching something. I need to go out, yeah. So we are there, and he's I need a little bit, just a little bit. Yes, now I'm actually touching the conveyor. My question is that now if we are in this position, if I go to the vacuum and say that okay, this is my, can you, and when I activate it, again, the sense part is that is something I don't understand. So I would like to delete this one first and see why basically my gripper is sensing such a weird thing. So I go again, I need to define a signal, a line signal sensor, and okay, connect this one of course to deactivate, and the sense part to the child, and sensor out as well to the execute one. And then here I need to define the position. So I need to jog my robot again to bring it up. Okay, and here maybe if you see it better. So I go again back to the vacuum line sensor, then I come here and say that okay, please select this position for me, and in Z direction we need to define maybe instead of I don't know, 900, because everything should be the same. No, the radius I make it 7. So is it correct or 1? Oh, it's too much. So I don't know, 700. No, it's also 900. Yeah, almost. So 1000. Something like this. This is not direct because it should be actually direct. Why there is a difference? So 3105. Yes. And 1751. Oh, it's minus, sorry. Minus. Yes. Okay. Now it's getting better. Now we have sensors here. Okay, now I think it's fine. You can save it. And then when we have everything, we need to now to know if it can actually. Oh, at first we need to synchronize what we have done. So we will sync everything. We will save it. And then we will sync everything to the rapid because we have created everything. So I will create this one, and then I will load everything to the controller.